in our surroundings. Learning about factors affecting evaporation. Evaporation. When a liquid is left exposed to air, its volume decreases gradually. This is due to evaporation. This phenomenon of change of a liquid into vapors at any temperature below its boiling point is called evaporation. Factors affecting evaporation. The evaporation of a liquid depends mainly on the following factors. 1. Temperature. 2. Surface area. 3. Humidity. And 4. Wind speed. Temperature. The rate of evaporation increases on increasing the temperature of the liquid. When the temperature of a liquid is increased by heating it, more particles of the liquid get enough kinetic energy to go into the vapor state or gaseous state. This increases the rate of evaporation. Thus, the rate of evaporation of a liquid can be increased by heating it. The rate of evaporation of a liquid becomes maximum at its boiling point. Surface area of the liquid. The rate of evaporation increases on increasing the surface area of the liquid. If the surface area of a liquid exposed to the air is increased, the rate of evaporation of the liquid increases. For example, if the same liquid, say water, is kept in a test tube and in a china dish, then the liquid kept in the china dish will evaporate more rapidly because more of its surface area is exposed to air. In our daily life, we spread out the washed wet clothes while drying to increase their surface area for the rapid evaporation of water present in them, which leads to quicker drying of wet clothes. Humidity of air. The amount of water vapors present in air is represented by a term called humidity. When the amount of water vapors present in the air is small, the air appears to be dry and we say that the humidity is low. On the other hand, when the amount of water vapors in the air is large, the air appears to be damp and we say that the humidity is high. So, humidity of air tells us the degree of dampness of air. When the humidity of air is low, then the rate of evaporation is high and water evaporates more rapidly. Under these conditions, sweat from our body evaporates rapidly and we feel cool and comfortable. The wet clothes dry quickly under the conditions of low humidity of air. When the humidity of air is high, then the rate of evaporation is low and water evaporates very slowly. Wind speed. The rate of evaporation of a liquid increases with increasing wind speed. When the speed of wind increases, the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surroundings. This increases the rate of evaporation of water. The washed wet clothes dry more quickly on a windy day because evaporation is faster due to the high speed of the wind. How does evaporation cause cooling? In the river, the liquid keeps on evaporating. The particles of liquid absorb energy from the surrounding to regain the energy lost during evaporation. This absorption of energy from the surroundings makes the surroundings cold. After a hot sunny day, people sprinkle water on open ground because the large latent heat of vaporization of water helps to cool the hot surface. Why should we wear cotton clothes in summer? We should wear cotton clothes in hot summer days to keep cool and comfortable. We get a lot of sweat, pasina, on our body in hot summer days. Now, cotton is a good absorber of water. So it absorbs the sweat from our body and exposes it to the air or atmosphere for evaporation. The evaporation of this sweat cools our body. The synthetic clothes made of polyester, etc., do not absorb much of sweat, so they fail to keep our body cool in summer. A fan increases the rate of evaporation of sweat or moisture from our skin and makes us feel cool and comfortable. Why do we see water droplets on the outer surface of a glass containing ice-cold water? To show the presence of water vapor in air. Water vapor comes into the air from the evaporation of water present in ponds, lakes, rivers, and oceans. We will now describe an experiment to demonstrate that water vapor is present in the air. Activity. The presence of water vapor in the air can be shown by the following experiment. We take a steel tumbler and put some well-crushed ice into it. Wipe the tumbler from outside with a piece of clean dry cloth so as to make its outer surface completely dry. Allow the ice-containing steel tumbler to stand undisturbed for about 5 minutes. A large number of tiny drops of water appear on the outer surface of the steel tumbler. This happens as follows. The air around the steel tumbler contains water vapor in it. When this water vapor comes in contact with the cold outside surface of the steel tumbler, they condense to form tiny drops of liquid water vapor in air. Let us take some ice-cold water in a tumbler. Soon we will see water droplets on the outer surface of the tumbler. The water vapor present in the air, on coming in contact with the cold glass of water, loses energy and gets converted to liquid state, which we see as water droplets. Summary. Evaporation is a surface phenomenon. Particles from the surface gain enough energy to overcome the forces of attraction present in the liquid and change into the vapor state. The rate of evaporation depends upon the surface area exposed to the atmosphere, the temperature, the humidity, and the wind speed. Evaporation causes cooling. Latent heat of vaporization is the heat energy required to change 1 kilogram of a liquid to gas at atmospheric pressure at its boiling point. Latent heat of fusion is the amount of heat energy required to change 1 kilogram of solid into liquid at its melting point. That's all in this chapter, students. Keep learning. Learning is fun.